One of the things that I like best about math is that there's a reason for everything. There's an explanation for why things are the way they are. And so, for example, when you see the quadratic formula, it seems sort of mysterious and and hard to imagine. But there's really a very good reason for why it is what it is. And I'd like to take a minute and show that to you right now. So what we're going to do is we're going to prove the quadratic formula. We're going to start with an equation of the form ax squared plus bx plus c equals 0. And we're going to demonstrate that x must be equal to this expression over here. And so the way we're going to do that is we're going to start by writing our equation. And then we're going to assume that a is positive. And that will make things a little more convenient later in our work here in a few minutes. And of course, you can imagine that a would be negative sometime, but if it is, then you can take that equation and you can divide through by the negative and make a positive. So I haven't lost any. We say that without loss of generality, we can assume that a is positive. And so then the big idea is just to complete the square. And so that's what we learned to do in the previous video. What we said is that if the coefficient on x squared is not equal to 1, then we should divide that coefficient off. And so we're going to divide both sides of this equation by a. Let's write it out. Let's write ax squared plus bx plus c is equal to 0. Let's divide both sides by a. And then what does that get us? Ax squared over a is just x squared. And then the coefficient on x is going to be b over a. And then the constant will be c over a. And on the other side, we still just have 0. 0 divided by a non-zero number divided by a gives us 0. Okay. So then the second step in completing the square is to move the constant over to the right-hand side. So we're going to subtract c minus a on both sides. And we'll get x squared plus b over a times x is equal to negative c over a. And of course now what we want to do is complete the square on the left-hand side. We want to make a perfect square trinomial. And so do you remember that process? You take the coefficient on x, which in this case is b over a, and you take half of it, and that gets you b over 2a. And then you take that and you square it. And that gives us b squared over 4a squared. And so that's exactly what we need to add to both sides of the equation. X squared plus b over a times x plus b squared over 4a squared is equal to negative c over a plus b squared over 4a squared. Okay, Now, this might look like a mess, but it's not too bad. We need to factor this left-hand side, and that might be difficult to do, except we actually have the key right here. So this b over 2a might not have seemed very important in this step might not have seemed important in previous examples, but actually it tells us how to complete the factor when we're factoring the left-hand side. And so that b over 2a tells us that we can factor the left-hand side as x plus b over 2a squared. And you might want to take the time to multiply this out and demonstrate it for yourself. Of course, there's an x squared, which is right here, and then b over 2a gets squared to make the b squared over 4a squared. And then you just have to convince yourself that the middle term is this b over a times x, which it is. Okay. And then on the other side, we just need to combine we just need to add these fractions. We need a common factor. Excuse me, we need a common denominator. And so if we have an a here and a 4a squared here, our least common denominator would be 4a squared. And so the 4a squared in the second fraction is fine. In order to get 4a squared in the first fraction, we need to multiply it by 4a. And so again, to get the denominator 4a squared, we had to multiply this denominator a by 4a. And so then we just multiply the numerator by 4a as well. And so that gives us this fraction right here, plus b squared over 4a squared. And then, since the denominators are the same, we can just add the numerators. You could write minus 4ac plus b squared, but isn't that the same as b squared minus 4ac? So that's nice. And then on the other side, we'll just bring x plus b over 2a squared along. Okay. And now we made our perfect square trinomial and we factored it, and now we're ready to use the square root property to finish this off. So the square root property just says that I can drop the square on the left hand side if I just do two things on the right, a plus or minus and then a square root. In the numerator I have b squared minus 4ac, and in the denominator I have 4a squared. Let's see here. Let's go ahead. Let's leave the b over 2a where it is for right now. And then let's take the square root of the numerator and the denominator separately. And in particular, what's interesting is the numerator doesn't simplify, but it sure looks familiar. It looks like part of the quadratic formula. And then the denominator does simplify. When we take the square root of 4a squared, well, when we take the square root of 4, we get 2. And when we take the square root of a squared, we get a. And that's the little moment where we needed to make sure that a was a positive number. If you think real hard about it, if a were negative, then that wouldn't quite work out. We don't have to worry about that because we said at the beginning a was going to be positive. There's just one more step. It's to subtract b over 2a from both sides. And can you see where we're going to get to? Let's put this fraction first, negative b over 2a first, plus or minus, square root b squared minus 4ac all over 2a. And then since the fractions have the same, since the two fractions have the same denominator, we can just add the numerators and get negative b plus or minus square root b squared minus 4ac all over 2a. And that's it. That is the quadratic formula. So that's a pretty good feeling. Next time you're sitting with your classmates studying and you see the quadratic formula and they say, where in the heck did that come from? Well, you know where it came from. And in particular, it came from completing the square on this arbitrary quadratic equation. That's all for section 1.4. We'll go on to 1.5 next.